Why is Chris? What?
Come on.
Why is he so deals about just paper?
Stop it.
Sabrina, what are you doing?
I don't know. It's
Killed it.
no, I did not.
Killed it.
What? Okay.
Okay, good. This will right second.
Three seconds. 3. 1, 2, 3.
Let's see if you get it then.
Okay, then we have like we just the one there.
Okay, we'll have a look at this now. So we have gx equals minus 1 over x minus log x, and its derivative is equal to 1 over x squared minus 1 over x.
Yeah.
Why it's not x minus
How
1?
did you know it was the
Hang on, stop. Stop. One at a time. Now go ahead.
Why it's not like we get the x up and x minus 1?
Like this.
Yeah.
Yeah, it is that. And then what's the derivative? X minus 2 minus 1 over x. And then you put in 1.
What?
Oh,
my
think it's
God.
stupid.
I got 2.
So I actually got 0. I'm kind of smart, probably, maybe.
Okay.
It's a dev, very strong dev.
Right, you got that?
Always the log x derivation is 1 over x.
Oh, it's in the formula book. Remember all the table I gave you?
But how did you know? So the derivative. Ah, okay.
Trying things.
I didn't see it.
A key step in solving the question is reading it. Right. It's in the formula book is in the exam with the derivative table. Okay, did you write that down if you need to? Yeah. Okay. It wasn't a very, very difficult one linear, one quadratic. Was this it?
Yeah.
Yeah. So, yeah, what method here? Just equate them.
Plus 3.
Oh, sorry. Plus 3. What method here? Just equate them, huh?
Yeah.
So, what is nice here is we can cancel that and that. Yeah, so we get x squared equals 1. So x is 1 or minus 1. And the y value is x plus 4. So that's 5, 3. Now that's very good for, what was this, 4 minutes, 4 marks?
Saves time at least.
Hmm?
Saves time
Yeah,
at least.
yeah. Yeah, well remember I said the recommended time for a question is the number of marks plus or minus 1.
Oh, that's too much.
Well, I don't know. Like this one here, I think even 3 minutes is too much for this one.
1 minute.
One, 1 minute is okay. Right, another one. Let's have a look. So what should I do, Ray?
Huh?
What should I do?
Let's put 1 back in.
Yeah, 1 plus 9 plus 8 plus 4 is 22. 5 seconds? Yeah.
Okay.
Okay, now you see? You see? Don't be so cocky, okay? Right?
Wow.
What was it? Was this, wasn't it?
Yeah. I have to cool down. Cool down a little bit.
Is it in decimals, the answer?
Yeah, 4 significant figures. You got it, Camille? Yeah. Right, let's have a look here. So the first thing is integrating the 1 over x plus 3. So what do you get here?
1, then?
Yep, x plus 3.
Yeah.
And careful here. Yeah.
Minus 3e power of negative 3x.
Oh,
No.
no.
We.
No. Nearly.
Uh,
Over 3.
Why isn't it plus?
Why is
Oh.
Where?
No. The -3 becomes
The minus 3 comes into the denominator.
Okay.
If you want, you can think about it like this.
Oh.
What?
What?
Hold
yeah,
on.
yeah, that's
Oh, I forgot that the first part was
But
plus.
isn't it we take the negative 3 down?
That's derivative.
And
For integration, it goes under.
Oh.
Yeah.
Oh.
So you have to put in 2 and minus 1.
Yes.
So that would be log 5 minus e minus 6 over 3
Yes.
minus log 2 minus e 3 over 3. Now, what do you get when you type that in on the calculator?
7.611.
7.611. What was after the 1? Are you rounding up or down?
No, 106.
It was 106.
Okay, so you were rounding up then. That's 4 significant figures then.
That's okay.
Yeah.
I was confused.
Yeah, yeah. Yeah, that's a minus 6 there because you put in the 2 and then you put in the minus 1. Yeah. Okay.
Because for the E,
Yeah.
I thought you were just gonna do like just like a 1 in front of it, and you just take it up instead of dividing.
Yeah, yeah, to be careful not to mix it up with derivative rule. You know.
I thought like since it's like that, just the backwards stuff.
Oh, that the one up here goes at the top.
Yeah.
No, no. Be careful with that now. Okay, you got that? Yeah, let's have. So, yeah, give me, what were the two sides here?
17 and 12.
And the area was
51.
51, was it? I think you all got this, no problem. The area is a half the two sides sine the angle. So what you get, sine C equals a half. So C is sine inverse a half, which is 30 degrees. Yeah?
I have a question.
Yep. Which part?
Sometimes I don't know how to explain it.
Try, that's okay, go ahead.
Sometimes like we didn't you draw like a line and a triangle.
Yeah, you mean like this?
Yeah, and make it like a right triangle.
Yeah. Sometimes we have to do that here. I'll give you what would be a part 2? Like imagine that this was part 1 of a question. What might be a part 2? Like Haza was asking me, what would be a part 2 that would make me want to do something like this to get the answer? Find the height, yeah? Yeah, find the height. So you can now use, but you see, it doesn't really work. Maybe they might say something like find this length. If we turn the triangle, find the height here. You could say a half the base by the height. What does that equal? What's that? Yeah, what's the formula for area? So you're right, Hazard. Typically, a follow-up question to this would be to find the height. Maybe in section B. Be something like that. Okay. Let's have a
The first is gonna be 7, then we substitute 7.
Okay, well, let me write it down. So, what was the y? Y equals x cubed plus 7. So, dy dx equals 3x squared, and we need to make that equal to 0. So that means the x is 0, and the y would have to be 7. The y. Now, because the reason I'm getting the y is because they said find its coordinate. So you need the x and the y. However, we're not finished because we need to confirm it's an inflection point. Yeah. So, the second derivative is 6x. However, when you make x is 0, this here is also 0.
Yeah.
And that, if we remember, the flow chart means we're not finished. We have to calculate a third derivative. And the third derivative here will be 6, which is positive. So in situations where we have a 0, and a positive, the flow chart brings us to rising saddle.
Yeah, right.
So therefore, it's a rising saddle. And remember, we said this in class, all saddle points are also inflection points.
Yeah.
Remember we said that?
Yeah.
All saddle points are also inflection points, but what's the second half of this sentence?
All the opposite, all inflection points are not saddle.
That's it, yeah. All saddle points are inflection points, but not all inflection points are saddle points. So it's a rising saddle, and saddles are also inflection. They spell it with an X, which I don't like.
But why did you make x equal 0?
That was the we got X is 0 at the beginning.
Uh-huh.
No. She's asking. You asked me where I got this from.
Yeah.
Yeah, it's from solving this.
Because it doesn't equal 0, it equals y.
No. This is the derivative equal to 0. Why do we make the derivative equal to 0, Hazza?
Because to get the
Exactly.
but from where did you get the 7 and the 30?
Where did I get the 7?
Yeah.
Where do you think I got it?
From the
The 7's a y. How would I get a y?
by making x equal 0.
Correct. Together, you can do the question. Teamwork.
You should sit here, Joe.
You should actually, yeah. Works better that way. Right, so write that one down. What's David saying?
The shades.
What? I don't know what he's saying. Did you watch Rick and Morty?
Sir,
Did you watch it?
I watched it.
Which one? The new
Everything.
ones? All of them. You
Yeah.
binge watched the whole thing.
Yeah?
You binge watched 3 seasons.
And the new
And the new ones. Wow. Did you do that like over a weekend or something? Yeah.
Or night.
Or night, yeah. My favourite episode is still Pickle Rick.
Exactly. Pickle Rick. Pickle
Still-
Rick.
It's still my favourite episode.
His favorite episode is Evil Morty.
It's Tales from the Citadel.
Oh, that's a good one too.
Thank you.
That's a good one too.
I just like some
It's just not better than Pickle Rick. 'Cause
Yeah.
Pickle Rick is Pickle Rick. He killed a rat.
Really?
Yeah, it was very disgusting. Yeah, that's still number 1. But we'll make Citadel of Ricks could be 2, I would say. That's fine. Right, you got that written down?
Yeah.
Yeah. Okay, let's have a look. All right. Oh, good. Okay, so Hazza, since you said Pascal's triangle, I'll just use Pascal because
But we have to make it in 3 times. So we just use 4, 3, 2.
yeah, you just need the first 3.
Yeah.
Yeah. So this will be 3 plus x bracket 1 minus 5x plus 4 1 minus 5x plus 6. I run out of space here.
Yes.
Plus 6
One.
1 minus 5 minus 5x dot. And I actually don't care about the rest because I'm only looking for
3 times.
3 terms, correct, yeah. Now, I have to put in the powers. Now, I have to be very careful, because they say they want ascending powers of x.
So we start at 0.
Which one starts at 0?
Negative 5x.
Yeah, very good. That's it. And this one?
4.
3, 1, 2, 2. So this will be 3 plus x times 1 minus 20x, isn't it? Minus 5 times 4, and then minus 20, plus 150
Yeah.
x squared, and then the rest we don't care about.
Yeah.
Now we have to do multiplications,
Yeah.
but I don't have to do all the multiplications. I just need the ones that will make a quadratic. Okay, so I'll have to do 3 times all of these. So let's do that one. I'll do it in green here. So that's 3 minus 60x plus 450x squared.
Yeah.
But I'll just need to do 3 times, x times 1, I'll have to do. X times 20x.
Yeah.
Yeah. But will I need to do x times x squared here?
It's gonna be cubed.
Yeah, which is too far now. So I just have to do 2. So that's plus x minus 20x squared, and the rest I don't care about.
So now we add them.
And now we add them, yeah. So that's 3 minus 59x plus 430x squared. Dot, dot, dot.
How do you know it's too far?
Well, because they want the first 3 terms, and you can see what's happening here, cubics will be too much. It'll be a 4th term.
Yeah,
Yeah.
sorry.
But you said we have to multiply them at the beginning. So isn't it like 3 times 1 and x times 5?
I thought what you were asking me was, do you add these and then expand?
Yeah.
But you notice I first expanded and multiplied, and then I only added at the end. I thought this is what you were asking me. What was it? Something else you were asking me? Or?
No, it's right. But I think like we will multiply them at the beginning. I think we have like one thing.
Yeah.
Oh. But you don't need to because it's only one time, so it's one term.
Hang on. I just want to perfectly understand your question. So, what were you thinking you would do?
To multiply first to make it 1.
Oh, multiply here,
Yeah.
and then power 4.
Yeah.
Yeah, we can't do that because. Well, what's the reason we can't do that?
But it's only the first 3 terms. and
No,
then-
that's not the reason. I want to know why don't we multiply these at the beginning and then do the power 4?
It's the rule. That's the way we live.
Yeah, okay.
We don't
Fine, yeah. Well, let me rephrase it. Under what situation could I do that? How would I slightly change this question so we could do what Haza asked, which is multiply these 2?
If the lower are the same.
Very good. If there was a 4 here, we could do it. Otherwise, we can't. Yeah. And in fact, if the powers were the same, then multiplying them first would be a good idea. Why?
Easier.
Yeah, but why? What makes it easier?
The
You
expand.
don't need to do that. Second.
Yeah, why is the expansion easier? Because there'd only be one expansion. You see, if you left it like this, you would have 2 things to expand.
Yeah.
But if you multiply it into 1,
There'll be 1 thing.
then it's 1 expansion. Okay? Okay, we'll do one more question now. Do you need to write that down, or do you have it?
Just
Got it?
a second.
Yeah. Yep, okay, so we'll do. Oh, that's a straightforward one, actually. Because there's no limits. Yeah.
What am I looking for? Oh,
This one.
There must be something in the end.
No.
No, in the end. There must be something.
Try.
Just be grateful for your egg.
Integration.
Is it antiderivative?
Yeah, make sure you don't forget that. Can I see?
Yeah. Oh no. Yes, yes, yes.
Is that a plus or a minus? I can't see the number in front of the tree.
Which one?
In front of the tree, is it plus or minus?
In front of 3.
Yeah.
Oh, I think it's pass.
And is that what you wrote? I can't tell what you wrote.
What?
What did you write in front of the tree? What the heck is that?
This plus.
Really?
This plus, yeah. Why is my oh man. Oh man.
No,
What does
that
that
doesn't
look
really.
like?
no,
What
no.
does that look like? Does that
Oh.
look like a plus or a minus in front of the tree?
Of course, minus.
Yeah.
What? Oh, this is bro. This is folding, right? It's
Yeah,
foldable.
yeah. You fold the page and ink falls off, is it?
So what do you think? Like,
I'm not
should Ray open a YouTube channel?
What?
Should Ray open a YouTube channel and entertain people?
That would be interesting to see. wouldn't it?
I'm not
You
that
could
stupid.
like,
That's an excellent name for your YouTube channel. And I can picture like a little logo or something, some cartoon logo. Yeah, yeah, yeah. Right, okay. I don't think you need the full 4 minutes for this because there's not even any limits to put in. It's just the antiderivative rule. So, the first one, if you integrate this, it would be 8x power 4 over 4.
Yes.
And then this one would be minus 12x power minus 3 over minus 3. Yeah. And the last one,
3x 0.
no, 3 log x.
Why?
The integration of 1 over x is,
Is it 1 over x?
yeah, it's x minus 1. So that becomes log x.
No, is it based
It's
on-
the antiderivative of
Yeah, so
8x
it's hence.
plus 3
No.
4x.
8x power 3. Yeah, we'll have to simplify it. It would be 2x4 plus 4x minus 3 plus 3 log x plus c.
Yeah, that's one.
Yeah, you got that? Yeah, good. That's the answer then for this one. Okay.
But the 3x minus 1.
Yeah, that becomes log x. Integrate, look, has a 3 over x, becomes 3 log x. Yeah,
it's like
one of the rules.
just for 1 over x.
Yeah, only for that one.
So
Yeah.
it, again.
Watch. There's a special rule. If you want to integrate 1 over x, the answer is log x.
Well, this is 3 over x. So
3 is constant. It's like a constant. So you
Yeah.
take out.
I didn't
Yeah.
did x power 4. I did 4x power 2.
Oh.
No! Increase the power. You decrease the power. Increase the power. 3 becomes 4.
Oh, right.
Yes. Okay. Yeah. Now, I'll just close that down.